In your audio plugins, you often want to allow the user to choose a parameter value out of the fixed set of values. For example, let's say you have a distortion plugin and you want to offer the user 3 different types of distortion. The user may select the distortion type from a drop-down list, also called a combo box or a select element, and based on their input, the algorithm that processes the sound changes. So the distortion algorithm changes. And this kind of setup with a parameter that allows a choice from a fixed set of values and a combo box in your GUI, a drop-down list, has been traditionally possible in the JUCE C++ framework. Now, with JUCE 8, you get the possibility of having the same real-time audio parameter control in your web-based UI, in your WebView. And WebViews, just as a reminder, are technologies that allow you to embed a web-based graphical user interface like a web page inside your desktop applications, and with JUCE 8 it is now possible in plugins as well. So in this tutorial, I will show you how to set up your parameter processing that takes one value out of a fixed set, how to control it from a C++ GUI as it has been traditionally possible with JUCE, and how to create a web-based control as it is now enabled in JUCE 8. Hi everyone, I am Jan Wilczek. I'm the founder of the wolfsound.com blog and YouTube channel on audio programming, and welcome back to the tutorial series on WebViews. As usual, the tutorial project that we are working on is available on GitHub, and the link to it you can find in the description below. Please don't forget to check it for possible changes to the tutorial content. In this tutorial episode, we are going to look first at how the classes involved in controlling a value, a parameter from a fixed set of values is set up in JUCE, and we'll show how to control it via classes from a C++ GUI and from a web-based GUI. So we'll discuss the classes involved in detail. And then we'll actually proceed to implementing distortion processing in the audio processor using 2 different types of distortion and lack of distortion, and we'll show how to control this parameter from a C++ GUI in practice and from a web-based GUI. First, let's take a look at classes involved in controlling such a parameter value that is chosen out of the fixed set of possible values. At the root of it is an AudioParameterChoice class. This class instance probably lives inside an audio processor value tree state that is a member of our plugin processor. And what this AudioParameterChoice class allows is submitting a set of values, a set of strings, for example, names of our distortion algorithm, and it also holds an index which of these options is currently selected by the user. And the traditional way to control this parameter was via a JUCE ComboBox in a C++ GUI. And this combo box is simply a drop-down list, and you connect these 2 instances with the ComboBoxParameterAttachment. And this class instance listens to changes in one of these instances, and if such a change occurs, it notifies the other. On the web side, it is similar, yet a little bit more complicated. So again, we have this AudioParameterChoice. It doesn't change. And instead of this ComboBox class, we have a relay class here. What is a relay? I'll explain shortly. Just notice that this relay class is kept in sync with the AudioParameterChoice via a WebComboBoxParameterAttachment. And again, this attachment class listens to changes in the AudioParameterChoice and to changes to WebComboBoxRelay. And if a change occurs, it notifies the other of these 2 elements that this change happened. Okay, so what this relay class does is that exposes ComboBoxState object in JavaScript. And we can interact with this ComboBoxState object from our frontend JavaScript code. And how we implement this drop-down list is entirely up to us. We can choose any web technology that we like. But, for the sake of this tutorial, we'll use an HTML select element that has just, a tiny bit of front-end JavaScript code to interact with this ComboBoxState. And, on the right part of the diagram, we just implement this bit and the connections between these classes. Of course, we have to instantiate them. And on the C++ side, we just instantiate these three classes, set up the connections, and maybe possibly style, the combo box. But that's essentially it. So that's how we'll proceed. We'll start with using an audio parameter choice to control our distortion type. And then we'll implement a traditional ComboBox-based C++ GUI in JUCE. And finally, we'll end with an implementation of a drop-down list or combo box or select element in a WebView using JUCE 8. And these ones will work exactly the same in controlling audio parameter choice, and all these class instances will be in sync. So now let's start with a C++ GUI. So if we open our plugin processor.h header file, we'll notice a couple of changes. So in the last tutorial episode, I criticized a little bit the usage of dynamic casts in the constructor of our plugin processor. So now we've eliminated them, and this has been possible thanks to the following changes. So one thing is that audio processor value tree state is now a private member, and it is retrieved via a getter, and reference to it is retrieved via a getter. And to hold our audio parameters, we now have a parameters struct that is private to the plugin processor. And this create parameter layout function is now a private static function, and we pass the parameters to it to allow the parameter struct to be initialized. And the parameters are a member of plugin processor. So our plugin editor, to access the state, it just needs to call the getState member function. But to add a new parameter, the set of steps is the same. So first we need add a parameter ID. So we go to parameterids.h, and here we add const JUCE parameter ID distortion type, and the name is distortion type, and the version is 1. Okay, so that's all we need to do in parameter IDs. And next we need to do is we need to create an audio parameter choice here in this parameter struct, audio parameter choice, and we'll call this distortion type null pointer. And now we'll go to this create parameter layout function so that we can create our parameter there. So it's here at the bottom of plugin processor file. And here, as you can see, we create first the parameter as a unique pointer. Then we retrieve the pointer to it, to the parameter struct, and then we add it to a layout. Of course, we need to move it because it's a unique pointer. And with this choice parameter, we'll do exactly the same. So we'll open curly brackets so that this parameter instance does not outlive its moving. And we go auto parameter assign stud make unique audio parameter choice. And here we pass ID distortion type. The parameter name will be distortion type. And now comes the string array, which is an array of options that we allow the user to choose from. So we go string array, and the first option will be none, so no distortion. Then the next option will be tan h of kx divided by tan h of k. So this will be one distortion type, and the other will be called sigmoid. And then the default option, default choice is 0, so none, the first one. Okay, so we created our parameter. Now we want to retrieve a pointer to it in our parameter struct. So we go, here the parameters are passed as a reference. So we go parameters, distortion type, assigned parameter get. So we retrieve a raw pointer to this parameter. And now we simply go layout.add stud move parameter. Once again, we need to use move because parameter is a unique pointer and unique pointers cannot be copied. And this function is called here in the constructor. So as you can see, we pass the parameters to create parameter layout, and create parameter layout initializes the fields in parameters and returns a layout that is passed to the audio processor value tree state. And this works because parameters are declared before the audio processor value tree state. So first parameters are initialized and then the state is initialized. So there, this function is called. Now is the fun part of implementing our distortion algorithm. So in the process block member function of audio processor, after clearing the samples that we don't need, and after checking for bypass, but before applying the gain, we'll apply the distortion. And how we can do it? Well, we first need to check which kind of distortion is set. So we go if parameters distortion type get index, and it is equal to 1, then we know that we want to apply tan h of kx divided by tan h of k distortion type. And then else if parameters distortion type get index equals 2, we know we want to apply the sigmoid. So these two distortions are classic distortion algorithms that are memoryless, which means that we can implement them using a simple application of a certain mathematical function to each sample in the buffer. Note that if the index is equal to 0, we apply no distortion, and that makes sense because our 0th option is none. So to apply a function to every sample in an audio buffer, we want to use JUCE DSP audio block float process function. But as you see, this function takes an audio block as an input, an audio block as an output, and a function to apply on each sample and to put into the other block. So out of our audio buffer, we need to create an audio block first. And this is very easily done. We go JUCE DSP audio block float, and we'll call this block, and we simply pass in a buffer. So if you don't know an audio block, it's simply a view into a buffer. So an audio block doesn't own its memory. When an audio block is destroyed, it doesn't free up any memory. Whereas buffer holds the allocated memory that contains the samples. So a block simply wraps a buffer here, and so we can use it here as an input and as the output. And here we'll put our distortion function. And the same structure will be present here, just the distortion algorithm will be different. For simplicity, we'll define a fixed saturation here. So we'll go const expr auto saturation assign 5 as a floating point value. And since std tan h is not const expr, at least not in C++20, then we need to use a static const auto normalization factor. And here we can compute the denominator of our distortion. So here k is the saturation, x is the input sample. So it goes std tan h, and we pass here saturation. Okay, and now our sample becomes, we can assign to it std tan h saturation, or k, times sample, or x, divided by normalization factor, and now we return the sample. So this is a simple mathematical function that will be applied to every sample. And for sigmoid, we have very similar thing. So again, we have saturation, const expr auto saturation assigned 5f, and you can change this value to a higher one if you want more distortion. Of course, you can also allow the user to control it. And then you go sample assign 2 divided by 1 plus std exp minus saturation times sample. And here at the end, we subtract 1, and we again need to return sample. Okay, so this is all the distortion that we needed to implement. And now to make sure, at the top of this function, we include #include juice DSP /juice DSP. That's what we need for the audio block and the process function. And we also include #include CMath for the ton H. Okay. And now we need to generate and compile our project. So let me open the terminal and let me generate the project cmake-s dot, because cmake lists.txt is in the root folder, and then -b I wanted to generate into the build folder. Okay, and now we go cmake --build, and this will build our project. Now that we have our parameter, we can proceed to implementing our traditional C++ GUI ComboBox. So let me go to plugin editor.h, the header file. And here in the list of members, we'll add a few additional ones. So what we'll add for clarity, we'll add a label. So we'll go juice label, distortion type label, and we'll name it distortion type label, and content will be distortion. Okay. And then we'll add the combo box. So we'll go juice combo box, distortion type combo box, and we'll name it distortion type combo box. And underneath it, we'll add a parameter attachment, juice combo box parameter attachment, and we'll name this distortion type combo box attachment. Okay, so we have these two members that are necessary for ComboBox implementation. Now we go to the constructor. Let me see. These are declared under button bypass button attachment. Okay, so we need to initialize them here. And here we go, distortion type ComboBox attachment, because that's the member that we need to initialize. And we again do the same as above. So we go, maybe let me put this on another line, processor ref get state get parameter ID distortion type, get param ID, and the second part is the combo box. So we go distortion type combo box, and as an undo manager, we pass null pointer because we don't implement an undo manager in this tutorial. Okay, and we need to, of course, dereference this parameter. Problem is that although this combo box attachment will keep in sync our parameter and our combo box doesn't have the options added by default. So that's what we need to implement in the constructor. And I want to add it here. So I want to go distortion type combo box, add item list. And I want to pass here the choices from the parameter. So I would like to have distortion type parameter, and I'd like to access its member choices, and then the offset will be 1, because that's what ComboBox requires of us. But we don't have this parameter, right? So for this, we need to get one distortion type parameter assign from processor. So we go processor ref, and now we need to create a getter like get distortion type parameter, get distortion type parameter. And this is a getter that we'll implement simply in the plugin processor header. So here underneath the get state, we again create a no discard function, and this will be juice audio parameter choice, and we want it to be a const reference. So we need to prepend it with const and append an ampersand after this. And this will be get distortion type parameter, and we simply return parameters distortion type, but we need to dereference it because this is a pointer and we want to return a const reference. Okay, so we have our parameter here and we use it to add items to our combo box. And finally, we need to initially set which of these choices is set in the combo box. So we'll go again, distortion type combo box, set selected item index, and we pass here distortion type parameter get index. And we don't want to send a notification because we don't want to notify the parameter that its value changed because it clearly hasn't. We're just retrieving it from the processor. And finally, we need to add and make visible. So we need to add the distortion box to our plugin editor component as a child. And finally, in the resized function, we need to add the distortion type label and the combo box. So we go distortion type label, set bounds, bounds remove from top. And here we pass in 50 and reduced 5. Okay, and we do exactly the same for the distortion type combo box. And of course, we need to add and make visible distortion type label. So now this is time to build our plugin and see if it works as expected. Cmake --build, build. Okay, our plugin built. So let me run this. I'll go to build, plugin, JUCE WebView plugin artifacts, debug, standalone. Here's the exe file. I'll go copy relative path and let me paste it here. Okay, as you can see, we have our label here. We have the type of distortion that we can use. And the WebView doesn't work because we haven't started our development server yet. But we won't test the audio right now. We'll wait until the WebView part is implemented, and then we'll test it in a digital audio workstation. So now let's implement with the WebView implementation. So we'll start with the C++ bit of the WebView, so with the C++ backend. So we need to go to plugin editor.h, and as we said, we need this JUCE WebComboBoxRelay web distortion type relay class instance, and we also need a parameter attachment. So we go JUCE WebComboBoxParameterAttachment web distortion type ComboBoxAttachment. Okay, so these are the two class instances that we need, and we need to initialize them in the constructor. So here below these relays, we go web distortion type relay, and we pass here ID distortion type get param ID, and that's all we need from the relay class. And here under web attachments, we'll add another one. Go web distortion type ComboBox attachment, and here we pass processor ref get state get parameter ID distortion type get param ID, and we'll pass here the relay class web distortion type relay, and as an undo manager we pass in a null pointer. And finally, in the initialization of our WebView, so a web browser component, in the options that we pass to it, we need to pass the options from the relay class. So we go dot with options from web distortion type relay. So this is all we need to do on the C++ backend side. And now we can proceed to the frontend implementation. So we go to index.html, and here below our checkbox, we can add another line break to separate this component. And here we go, label for distortion type combo box. and we name it distortion type. And here we put a select ID assign distortion type ComboBox. And we close it off. And this is all that we need in our HTML. Now let's go to our index.js. And here the matter is also quite straightforward. It's very similar to what we had with the bypass checkbox. So first we retrieve our ComboBox. So we go const distortion type ComboBox assign document get element by ID. And we type here distortion type ComboBox. Now we need to retrieve this ComboBox state from the JUCE framework. So we go const distortion type ComboBox state assign JUCE get ComboBox state, and we pass here distortion type. So that's the value that we passed to our relay class. As you remember, we named it exactly as the parameter, but you can change it to something else if you want. There's another step here, is that we want to be notified when the list of element changes, so that we can easily populate our select element with options that we got. So here we go, distortion type ComboBox state, and we go dot properties changed event, and we go add listener. And once this listener is added, we get access to all the choices that are in this parameter. So we can go distortion type ComboBox state properties choices. So these are the choices that are available. And now for each choice, which is basically a string, we go distortion type ComboBox dot inner HTML plus assign option value assign choice. Then we here have the choice inside, and we close with an option. So this is kind of, mimicking dynamically generating inner HTML. So to clear this every time maybe this changes, we go distortion type ComboBox dot inner HTML assign an empty string. And now when this properties changed event fires, then we'll update our ComboBox with each of these choices by appending an option here. And as you can see, we pass here an option with value and label exactly the same as the name of our choice. And now we can implement listening to whether the selected value changed, and also notifying the C++ backend that the user changed it in the WebView. So we go now distortion type ComboBox state value changed event, add listener, and if this fires, then we go distortion type ComboBox selected index assign distortion type ComboBox state get choice index. Okay, so this is when the value in the C++ side changes, we update our dropdown, our select element. And now if the user changes the value in the WebView, we go distortion type ComboBox on input assign function, and now distortion type ComboBox state dot set choice index. So we interact with a JUCE frontend framework. Go this selected index. Okay, and maybe one more thing here. We used this JUCE object here to get the combo state. As you remember, this is what is called a JUCE frontend framework. So we import the content of the file provided by JUCE, a JavaScript file provided by JUCE. We import everything from it, as this JUCE shortcut. Okay, so actually this is everything that we need. Because we changed the C++, we need to recompile the project. So we go cmake --build build. Okay, now our project built successfully, so we can run this. Okay, this still doesn't work because we haven't started the development somewhere. So we go cd plugin UI public, and we go npx http-server. So this starts as server inside our public folder. So these files are now hosted. So let me run our plugin again. Okay, as you can see, here it is. And if we change this value here, it also changes here, right? This is, as you can see, this is all in sync, but this is no fun because we have no input. So let's test our plugin in a digital audio workstation. And for this, I'm going to use Reaper, but just so you know, if I go here, build, plugin, JUCE WebView plugin, artifacts, and now debug. And here's this VST3 folder. I'm going to copy this JUCE WebView plugin.vst3 folder in a folder that is scanned by Reaper so that it can be discovered. Okay, I've copied the contents of the set folder to C drive, program files, common files, VST3 because I'm on Windows. And now here I have a sample track. So let me play it back to you without any effects applied. As you can see, it clips a little bit. So let's enable effects and let's go here. And as you can see, I have our plugin loaded already. So let me make it a little bit larger. And once again, let me play it. Okay, so it clips. So let me decrease the gain to half. Okay, you see that we have distortion as none. So let me change it to sigmoid. So you should be able to hear the distortion applied. Let me play it again. Okay, as you can see, it also changed in the C++ GUI. So let me now change it to ton H. As you can see, it changed in C++ GUI as well. Let me play it back. Okay, this is way harsher. So now what I can do, I can switch back to none. And as you can see, I do it in the C++ GUI and the WebView value changed as well. And the underlying parameter changed as well. So indeed, our distortion works as expected. So let me recap. What we created in this tutorial is applying 3 different types of distortion to our audio in an audio plugin. And we can control the type of distortion that is applied with an AudioParameterChoice class instance that allows us to select one value out of the fixed set. We've shown that we can control this parameter from the C++ GUI using a ComboBox and a ComboBoxParameterAttachment. This how it's been traditionally done in JUCE. But we've also shown that this parameter can be controlled from the WebView UI GUI starting from JUCE 8. And there the flow is a little bit more complicated because on the C++ side, we have a relay class and a parameter attachment class. And the relay class exposes a ComboBoxState object in a JavaScript. And this is the object that we can interact from our JavaScript frontend to get updates on the number of elements changed and the index of the selected one changed. And also we can notify C++ that the user chose one of these options. So the attachment classes keep the UI controls and the parameter itself in sync, but the web flow is more complicated in this case. As a final note, I wanted to say that the tutorial project on GitHub is available. The link to it you can find in the description below. This project gets updated regularly, also reflecting the changes in the JUCE API. If you have any questions or comments to this tutorial, you can put them here in the YouTube in the comments section, and you can also post them in the dedicated JUCE forum thread. The link to it you can also find in the description below. Of course, I encourage you to subscribe to this channel and to the Wolf Sound channel. And if you want to learn how to package your plugin with WebViews so that it can get distributed to your clients, turn on notifications, because that will be exactly the topics of the next tutorial video. Thank you so much and see you in the next episode. Take care.